Okay, we were discussing about derived method of principle of vector addition. Under that topic, we were discussing about vector triangle principle. Vector triangle principle used to add two coplanar vectors. Okay, Buddha? Two coplanar vectors. If we add two coplanar vectors using principle of vector addition, we will have a triangle. No, definitely we will have a triangle. Therefore, we can express this as a principle. This as another method. Okay, if we are given two vectors to add, then definitely we will have a triangle. That incident is given as a method. Okay, that method is called as vector triangle principle. Okay, then you have to clearly understand the characteristic of this triangle. If you consider the characteristic of this triangle, you can clearly see these two vectors that we are going to add are in same direction, no, into this direction, in order. They are in order, but the addition vector, the resultant vector is in the opposite way. If they are going in this direction, the resultant vector is going in this direction. Okay, that is the characteristic of this triangle. Okay, so if we represent two vectors, using a triangle, using the sides of triangle, then the other side will be represented the addition of these two vectors. That is the principle of not the principle. That is the another method of vector addition. That is called as vector triangle principle. Okay. The most important thing is you can add two coplanar vectors using vector triangle principle. If you want to add more than two vectors, you have to apply vector triangle principle again and again. Okay, that is the way. Okay, but if you are going to use principle of vector addition, that is the basic principle, you can add any kind of vectors at one time. Okay. Okay. I think you have copied this, Nick. If you copied this, write this under this figures. Okay. Write down this. If we add two coplanar inclined vectors, using principle of vector addition, using the principle of vector addition, we will always have a triangle. Sorry. We will always have a triangle. Therefore, we can develop this thing as a methodology. Therefore, we can develop this thing as a methodology. It is called as the vector triangle principle. It is called as the vector triangle principle. Okay. Write in another paragraph. This is the principle. Okay. You can write this principle. Principle එක ලියලා පොඩ්ඩක් කොටු කරගන්න. Okay. Principle එක. If two same type vectors, same type vector means if you are using forces, both should be forces. If you are using displacement or velocities, all the vectors should be vector velocities or displacement. That is the meaning of same type. Okay. If two same type vectors are represented in magnitude and direction. By two sides of a triangle. Two sides of a triangle. Two sides of triangle taken in order. The other side taken against the order will represent will represent the addition of about two vectors in magnitude and direction. That means if we represent two vectors by two sides of a triangle in magnitude and direction, the other side will represent the addition of those two vectors in magnitude and direction. Okay. So in that case, you should use two coplanar vectors. Okay, you have to use two coplanar vectors. That is the first condition. Other condition is you have to represent these two vectors by two sides of triangle in magnitude and directions. Okay, so it is you should represent those two vectors in magnitude and direction. Okay, that is a second mandatory thing. Okay, if you fulfill those mandatory requirements, then you will have the resultant vector by the other side. Okay. That means AB, if I add AB vector plus BC vector, I will have AC vector. That is the final expression, final equation. You can clearly see this one, no? This point and this point are same. These 2 points are same. That means these 2 points are overlap, or these 2 points are coincide. Okay, that is the reason of that. Okay, these 2 points should be same. If you write here COD, then this should be COD too. Okay, AB plus BC is equal to AC. AC means two free ends. This is the free ends of AB vector. This is the free end of BC vector. Then you will have the addition through AC vector. That is the principle of vector addition. Those should be same. If these two points are same, then definitely you can eliminate those 2 points and write these two vectors are equal to AC vector. Okay. So this is the principle of vector addition and principle of vector triangle, or principle of vector triangle, or vector triangle theorem. Okay. Okay. You can draw this one. Draw this triangle and write this equation. This arrowhead should be started from the starting point of the first vector and should be directed to the end point of the second vector, arrowhead. මේ කටපාඩම් කරන්න ඕනේ ඇත්තටම අර vector addition principle එක ඔයගොල්ලන්ට තේරෙනවා නම් මාරම ලේසියි උනේ. මේ vector triangle principle එක තේරුමක්ම නැති principle එකක් හරි. හරි. Okay. Once you complete writing, please let me know. Okay. Shall I erase this? Shall I erase this?
Sir, can you explain it again?
This one.
Yes, sir.
Okay. Good. Actually, can you so suppose A, B, and C, D. Okay. Do you have any problem with vector addition principle, Putu? Vector addition principle.
No, sir.
Can you explain me how to add these two vectors? How to add these two vectors? The first thing you have to do, you have to coincide the first the end point of the first vector and the starting point of the second vector, no? You have this kind of figure. Then there's a free two free ends. One is a starting point, other one is an end point. If you connect these 2 points, or if you construct a vector using these 2 points, then you will have the resultant vector. You will have the resultant vector. That is vector addition theorem, no? So, vector addition theorem can be used to add any number of vectors. It is not limited to 2 vectors. Okay, it is not limited to 2 vectors. We can use this thing to add any number of vectors. Okay. Vector triangle theorem means vector triangle theorem or vector triangle principle means if I use vector addition principle, if I use principle of vector addition for add 2 vectors, you will have a triangle. No. you will have triangle. So there's another theorem. There's another theorem. It is called as vector triangle theorem. Vector triangle theorem. Vector triangle theorem. Actually, it is not a separate theorem. It is some same thing which you have learned in principle of vector addition. Okay, but it can be used to only, maybe it can use to add two vectors only. Okay, if you add two triangle, you will have a triangle, the same triangle. You will have a triangle. So it can actually this result is developed as a methodology. That is the only thing they did. Okay, this result is developed as a methodology, vector triangle principle. Okay, vector triangle principle is not another principle, is the same principle that we have learned previously, principle of vector addition. The difference is principle of vector addition can be used to add any number of vectors, but if you add two vectors, you will have a triangle. So that is developed as another methodology. That is the thing. Did you understand?
Yes, sir.
What I said, what I explained here about this expression, suppose if you have this kind of triangle, now there's another only one point. No, if you coincide B, there's only one point. If I consider it as B, then clearly you can say the vector AB plus vector BC is equal to vector AC. Vector AB plus vector BC is equal to vector AC. Okay. Actually, I have shown some special characteristic of this equation. What is that characteristic? These 2 points are same. These 2 points are same. Why? What is the reason? Because according to principle of vector addition, I have overlap, or I have coincide these 2 points. That's why these 2 points are same. The end point of the first vector and the starting point of the second vector. So that is the reason. So what is the reason for that? Because when I am adding two vectors using principle of vector addition, I should overlap the end point of the second vector and the starting point of the first vector. Once I overlap these 2 points, these 2 points will become a single point. No, that's why these 2 points are same. Did you understand it? Did you get my point? Still not?
Yes, sir.
Okay, vector triangle principle. Right. Okay. I will give some note here. Okay. Right under this. When we are adding two vectors, using principle of vector addition, the end point of the first vector, the endpoint of the first vector has to be coincide the starting point with the starting point of the second vector. Therefore, if you write the above equation correctly, the endpoint of the first vector should be same as the starting point of the second vector. Should be same as the starting point of the second vector. Did you get my point? Okay. Because when we are writing some expressions, when you are dealing with vector additions, you have to write some expressions. So when you write in some expressions, addition expression, when you write in some expression for addition, you can check whether that is correct or not. How to check that one? If you write that equations correctly, the endpoint should be same as the endpoint of the first vector should be same as the starting point of the second vector. Okay. From that you can check whether your equation is correct or not. If it is addition, okay. Then second one. The second application is vector parallelogram theorem. Vector parallelogram. Vector parallelogram theorem. Okay. Suppose if you are given two vectors which are acting on a same particle or same point. Okay. Suppose there are two vectors which are acting on a same point, acting at the same point. Suppose this is the point A. These two vectors are acting at the same point. Suppose P and Q. If you have this kind of vector application, and if you want to add these two vectors, then we can use a parallelogram to get the addition of these two vectors. Okay, actually this is based on the principle of vector addition, but this is a special case. This is a special case, not like the triangle theorem. The triangle theorem actually it is not a big deal because it is something similar to the vector addition principle. Therefore, we can use either vector addition principle or vector triangle principle in our previous cases. Okay, but this is something different. This is something different. What is the difference? These two vectors should be at this point, at the same point, at the same point. In previous cases, these we have add two coplanar vectors. Two coplanar vectors, not vectors acting at the same point. Okay. So we have add two coplanar vectors only. We have two coplanar vectors only. So I can easily bring that vector to this location, and I can coincide the endpoint and the starting point. Then I can get the addition. Okay, I can do that. Okay, but this case is different. What is different? These two vectors are acting at the same point. Acting at the same point. That is the difference. It is something like force. This is something like force. Suppose there is a small mass. Suppose there is a small mass. A small mass can be taken as a point. Okay. Suppose there are two forces exerted on this mass, 5 Newton and 10 Newton. These two vectors can be considered as point vectors. Okay, because they are acting at the same point. Okay, so this kind of application can be used to solve this kind of practical situations. Okay, actually we are going to apply vector addition principle to solve this method, to solve this to find this resultant force. Okay, but the most important thing is we can memorize that equation. Okay. Okay. In our previous class, after completing the vector addition principle of vector addition, I have given some examples. No, in some examples you are given up to the upper direction, and there is another force in this way. Something suppose it is 10 also. Then you are asked to add these two vectors. You are given some angles here. So what you have done here, you have overlapped the endpoint and the starting point of the endpoint of the first vector and starting point of the second vector. Then what we have done here, you have construct two right angle triangle. You have construct two right angle triangle, and using your geometrical and trigonometric knowledge, you have evaluated the magnitude of the resultant vector, no? The magnitude of the resultant vector. Okay. I think you can remember that thing. Okay. In that in this particular question, Puta, actually you have to calculate the magnitude of the resultant force using your geometrical and trigonometric knowledge. Okay. In this case, the same kind of scenario will be there. Okay, the same kind of scenario, but the most important thing is now I am going to derive an equation to take this magnitude. Okay, now I'm going to take derive an equation. That equation can be used as a standard equation. That is the most important thing. Okay, and when you are calculating this magnitude of this resultant force, if you knew this equation, then actually probably you can do the questions very easily. But you have to apply your geometrical and trigonometric knowledge at that time. Okay. Now we are going to derive an equation to solve that kind of problem. Okay. Vector parallelogram theorem. Actually, this theorem is used to find resultant force of two vectors, resultant force of two coplanar vectors. Remember this thing, resultant force of two coplanar vectors which are acting at the same point. Okay, which are acting at the same point. Suppose this is P, this is Q. An angle between these two vectors are theta. Okay. Suppose this is B, this is C. This is B and C. Okay. Suppose you are given this kind of vector system. These two vectors are coplanar vectors which are acting at the point A. Okay. What is my second step is, now I am going to complete a parallelogram using these two sides. Suppose these two sides are adjacent sides, two adjacent sides of a parallelogram. Okay. Assuming that I can complete this parallelogram. This is my second step. Okay, completing the parallelogram. Okay. 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 So if this vector is q, you can okay. Suppose this point is BCD. You know, as this is a parallelogram, AC and BD are parallel and have an equal length. No, those are two parallel sides and have equal lengths. Therefore, if we consider the direction and magnitude of the BD vector, it should be equal to Q. Okay. Therefore, BD vector is an equal vector to AC vector. Okay. Therefore, I can consider this is as Q vector. This is not the Q vector. This is a equal vector for Q. See this. AB and BD. AB and BD. Look at this. The end point of the AB vector is coincide with the starting point of the BD vector. Therefore, if I construct a vector from A to D means A is a starting point. This is a starting point, Puta. A, it is a starting point. D, you can clearly see this is a end point. This is end point. So if I construct a vector from A to D, definitely this vector should be equal to the addition of AB vector plus BD vector. Did you understand? Did you get my point? According to principle of vector addition or according to vector triangle principle, you can use both of them. You can clearly understand AB plus BD vectors should be equal to AD vector. Did you get my point? Please give me your responses.
Yes, sir.
Thank you. Therefore, AD vector is equal to the addition of AB plus BD. You know AB vector. AB vector is equal to P. And previously I have shown BD vector is equal to Q. Look at this. What is the result? AD diagonal is the addition of P and Q. This is the vector parallelogram theorem, Puta. Okay. Did you understood? Did you get my point? In vector parallelogram theorem, it is say if there are two coplanar vectors acting at the same point, and if you complete a parallelogram using these two vectors, the diagonal of this parallelogram which is gone through this point is represented the addition of these two vectors. Actually, we have applied the principle of vector addition here, no? Principle of vector addition here, but we can use our trigonometric and geometrical knowledge to evaluate the magnitude and the direction of this resultant vector. Okay. Everyone, I need your responses. Did you get my point? Thank you. Okay. Then write a topic and draw this diagram. Don't write this one. Don't write anything. Just write the topic and draw the diagram. Okay. Okay. Have you complete writing? Okay, right under this diagram. Suppose P and Q are, suppose P and Q are two coplanar vectors, acting at the same point, If we want to find the resultant force of the resultant vector of P and Q, the resultant vector of P and Q, the principle of vector addition, cannot be applied directly. Okay, look at the board. What is my last sentence? What is my last sentence? What is my last sentence? If we want to find the resultant force of P and Q, the principle of vector addition cannot be applied directly. What is the reason for that? What is the reason? Why we cannot apply principle of vector addition directly? Tell me someone. What is the reason? Why I cannot use this thing?
So the two forces are actually they are opposite to each other. The vectors they start from one point and they are like normally in vector addition we take forces that are inclined and like they meet at the same point and they go towards the same side. same direction.
No, we can add two forces in any direction. Okay, direction doesn't matter, Puta. But the thing is, that's one thing. What is that? These two forces are acting at the same point. Acting at the same point. If you want to apply principle of vector addition, you have to coincide. You have to coincide the end point of the first vector and the starting point of the second vector. But in this case, both vectors are started from the same point. No, both vectors are started from the same point because they are acting at the same point. So you cannot overlap these two forces. You cannot overlap these two forces because they are started from the same point. That is the problem. That is the reason why I cannot use vector addition theorem directly. Okay, that's why I did some construction here. Okay, what is the construction? It is a parallelogram. Okay, it is a parallelogram. Using that parallelogram, I have created an equal vector. I have created an equal vector at the end point of the first vector. Did you understand? Did you understand?
Yes, sir. Yes.
That is the reason. That is the reason because these two vectors are acting at the same point. Therefore, their starting points are same. Okay. So I cannot overlap the end point of the first vector and the starting point of the second vector. I cannot do that. Okay. So I cannot apply the principle of vector addition directly to the system. Therefore, I have constructed construction here. Okay, what is the construction? I have constructed parallelogram. Okay, I have considered these two forces are two adjacent sides of this parallelogram and construct a parallelogram. Okay, if I construct a parallelogram, these two sides are equal and parallel to each other. Therefore, this side can be taken as the same, can be taken as an equal vector to Q. Okay. The most important thing is the starting point of this Q vector is already overlapped with the end point of the P vector. Okay. Then I can apply vector addition theorem to this system. Okay. That is the reason why I cannot use vector addition theorem directly and why I did a construction here. Did you understand? Did you get my point, Puta?
Yes, sir. Yes.
Okay. We can write it down, okay? Write another paragraph. Write in another paragraph. These two vectors are acting at the same point. Acting at the same point. Therefore, the starting points of both vectors are same. The starting points of the both vectors are same. starting point of the both vectors are same. So the endpoint of the first vector, endpoint of the first vector actually you don't want to write endpoint as a long format. Endpoint E dot P, starting point S dot P, write in short format. Okay. Therefore, the endpoint of the first vector, cannot be coincided with the starting point of the second vector. Due to this reason, sorry, okay.
So small questions. What if there were two forces that are not in the actual world? They are not starting from the same point, but if we arrange them according to the diagram that's on the board, as if their directions are towards the opposite side from each other, from away from each other.
Yeah. We can do that. Means actually there are classification of vectors, Puta. I will explain that thing later. Where there are some classification of vector. According to that classification, actually in our previous explanation regarding vector, I have mentioned the direction and the magnitude only. No? According to our definition of the vector, I have defined a vector as a physical quantity that have a magnitude and a direction. No, that is the common feature of any vector: magnitude and the direction. Okay. Further to that these two characteristics, some vectors have a point of action. Some vectors have line of action. Okay. Suppose force has a line of action. If you consider a force acting on a rigid body, it has a line of action, but it doesn't have a point of action. Okay, it has a line of action. Okay, it can be applied anywhere in that line, because it has only line of action. It doesn't have a point of action. Okay, it does. Suppose a force acting on a rigid body, this force can be applied anywhere in this line of action. Okay, it can be applied from here, doesn't matter. Okay, you can apply this force anywhere in this line of action, the result is same. Okay, it is a characteristic of force. Okay, this kind of vectors doesn't have a point of action. It just have a line of action and magnitude and direction. Okay, so if this kind of vector, if you are given this kind of vectors, Suppose F1 and F2. If you are given this kind of vector to add, actually, although they are not acting at the same point, although they are acting, they are acting not at the same point, you can extend their line of action. You can extend their line of action, and you can find the overlapping point or coinciding point. You can find this point. Then you can consider these two forces are acting on this point. You can consider these forces are acting at this point. You can consider these two forces are acting at that point, and then you can apply vector parallelogram theorem to get the resultant force. Okay. Did you get my point?
Yeah, sir. Got it.
Actually, these two forces are not acting at the same point, but we can extend their line of action and get a point of intersection. Okay, point of intersection. Then I can assume these two forces are acting at this point of intersection. Okay, because if we consider a force, it doesn't have a point of action. It doesn't have a point of action. Therefore, I can apply this force anywhere on its line of action. Okay. But if you consider a force acting on a particle, acting on a particle or some point, this is a rigid body, Puta. So if you consider a point, if you consider point object, if you consider point object, and if you consider force acting on this point object, this force have both line of action and point of action, because this is a point object. Therefore it has a point of action. If any vector has a point of action, you cannot change their position. Point of action means it is a rigid force, because this force acting at this point, acting at that exact point. Okay. Did you understand?
Yes, sir.
Okay, I will explain this thing lately, because once I did addition and subtraction and then resolutions, then after that I will explain this classification of vectors. Under the classification of vectors, we are going to study some specific features of vectors. Okay, point of action and line of actions. What are the vectors have point of actions? What are the vectors have line of actions? What are the vectors that have both? Okay, we will study this. Okay, then we can.
So, sir,
okay.
So for the time being, that means the vector parallelogram theory is only applicable for vectors starting from the same point. No, sir.
Vector starting point, same point, or this kind of application can this kind of forces this can be application. I can apply for this kind of application. Sorry.
Oh, okay, sir. Okay. Thank you, sir.
Therefore, vector parallelogram theorem, actually you can apply vector parallelogram theorem for vectors which are acting at the same point, or which are converge into a particular point, a certain point. Okay. So that is the feature of vector addition theorem. Okay. Actually, your question is a very good question, Puta, because most of the students do not have any clear idea about this theorem. Okay, they apply this theorem everywhere. Actually, we cannot do that. We can apply this theorem to vectors that are acting at the same point. Okay. There are in our in the beginning of the vector lesson, I have defined a vector as the physical quantity that have both magnitude and direction. Okay. The reason is that these two features are the common feature for any vector. Common feature for any vector, magnitude and direction. Okay. You cannot say about line of action. You cannot say about point of action when you define a vector, because there are some specific features. Okay. Those features are not common for every vectors. Some vectors doesn't have line of action, and some vectors doesn't have line of action and some point of action. They have only magnitude and direction. Magnitude and direction. Okay. You will learn about especially vectors in angular motion. You will learn about angular accelerations and angular motions, angular acceleration, angular displacement. If you consider about angular displacement, it is a angle of rotation. So angle of rotation, it is a rotated angle. Okay. Suppose this is a rod, and this rod is rotated theta angle around this point. Okay. Therefore, this theta angle is called as the angular displacement of this rod. Angular displacement is a vector. You can clearly see angular displacement is an angle. It is an angle. It is an angle. Therefore, it doesn't have a line of action. It doesn't have a point of action. It just have a direction. Normally, direction is from this side. This side means out of the plane. Okay, I will explain that in angular displacement when we are discussing about angular displacement. Actually, this kind of vectors doesn't have point of action and line of action. Okay, therefore, don't define vectors using line of action and point of action, because they are not common feature for every vectors. Okay, there are some specific features of specific vectors. Okay, for the common features for every vectors are the magnitude and the direction. Therefore, if you want to define a vector, use these two common features. If any physical quantity that have a magnitude and a direction, that kind of physical quantity is called as a vector. Okay. Did you understand or did you get my point?
Yes, sir. Yes. Thank you, sir.
Okay. What was my last sentence?
So it was so the endpoint of the first vector cannot be considered with the starting point of the second vector.
Sorry?
The last line was so the endpoint of the first vector cannot be considered with coincided with the starting point of the second vector.
Okay. Okay. Therefore, the vector addition principle cannot be applied directly. Look at the board. Now the vector addition theorem cannot be applied directly, no, Buddha. Now I have to add these two forces anyhow, no? Therefore, that's why I did some construction. Using this construction, I can apply vector addition theorem and get the resultant force. Okay, right under that paragraph, in another paragraph. Therefore, we have to do a special construction, that can facilitate the application of vector addition theorem. Vector addition principle of vector addition. Okay, right under that paragraph, construction. What is our construction? I will describe the construction. Considering AB and AC, considering AB and AC are two adjacent sides of a parallelogram, construct ABDC parallelogram.
So can you repeat that, sir?
Considering AB and AC are two adjacent sides. Considering AB and AC are two adjacent sides of a parallelogram. Construct ABDC parallelogram. A, B, D, C. A, B, D, C parallelogram. That is my construction, okay? Okay. Okay, once you complete ready, please look at the board. Okay, I have done the construction now. I have done the construction. What is my construction? I have considered AB and BC, AB and AC are two adjacent sides, and I construct a parallelogram AB, DC, AB, DC. Using that parallelogram, I can say AC side is equal and parallel to BD side. No, because ADC, AB, DC are, this is a parallelogram, because A, B, D, C is a parallelogram. Or you can because AB, DC is a parallelogram. Use this kind of symbol when you are writing, okay? If AB is AC and DC are equal and same in direction, those are equal in length and same in direction, that means AC vector should be equal to the BD vector. AC vector should be equal to the BD vector, because AC and BD are equal in length and same in direction. Okay, that means BD vector is equal to Q. That means BD vector is equal to Q. Then I can apply vector triangle theorem or vector addition, principle of vector addition. Both are same, no? Look at this, AB and BC. If you have add AB and BD, it should be equal to AD, because this is the end point of the first vector and this is starting point of the second vector. Okay. I can consider ABD triangle from ABD triangle. From ABD triangle, I can write AB plus BD. AB vector plus BD vector should be equal to AD vector. Should be equal to AD vector. Look at this. End point of the first vector is same as the starting point of the second vector. Therefore, I can eliminate these 2 points, and these are the 2 free ends. AD. Okay. Then AB plus BD is equal to AD. AB is equal to P vector, BD is equal to Q vector. Therefore, AD represents, AD vector represent the addition of P plus Q. Did you get my point, everyone? Did you understand? I need your response. Even at the I don't know.
Yes, sir. We understood.
Okay. All right. Okay. Then I can conclude. AD diagonal represent the addition of P and Q. It is equal to the addition of P and Q. Okay. Okay. Right. Now you have right up to construction, no? Right up to construction. Then you can write this one, okay? From here to here. We start from here and up to this one. Shall I erase? Okay. Right under this point, okay? Right on this point. That means the diagonal in between two vectors, the diagonal in between two vectors represents the resultant vector in magnitude and direction. Okay. Okay. Now we have shown that the AD diagonal represent the resultant vector. Okay. Now we are going to find the magnitude of this vector and the direction of this vector. Magnitude and the direction. Okay. Now we have shown this in a qualitative method. No, qualitative method means not a numerical method. It is a logical way. Now we have shown this AD diagonal may represent the resultant force in a logical way. Now we are going to quantize. That means now we are going to find the magnitude of R and direction of R. Magnitude of R means you have to find the AD length. It is obvious, no? You have to find the AD length because magnitude of R equal to AD length. The direction. Direction. Normally we define the direction is the direction between P and R. Is the direction between P and R. Okay. Right. Let's find the magnitude and the direction. Direction is, normally we define the direction is direction in between P and R. Okay. This angle. Okay. This angle. Okay. Now we are going to find the magnitude of R. Magnitude of R. Right under that paragraph. Right under the paragraph. Let's find the magnitude and the direction of the resultant vector. Let's find the magnitude and the resultant of the magnitude and the direction. Let's find the magnitude and the direction of the resultant vector. Okay. This is something same as what we have done in previous class. When we are finding the resultant vector, using vector triangle, vector addition theorem. Okay. In that case, actually we have determined this kind of cases. Using your previous knowledge, please tell me this, give me a proposal how to find the magnitude of R. How to find that one? Give me a proposal. Magnitude.
So can we use the unit circle? The unit circle.
Why?
Be known. Because at the moment we don't know the true numerical values of the vectors, so we can't really use trigonometric values.
No. You don't want to use numerical values. You can find the value of R using P and Q and theta. Those are the known values. Okay. P, Q and theta are the known values. Okay. Although they are not numerical values, but they are known values. Okay. Something like X, Y, and Z. Okay. So you can, actually you have to find R. You have to find R using P, Q, and theta. P, Q, and theta. Okay. So you will have an equation for R in using in P, Q, and theta. R. Actually, when you are finding the magnitude, of a length of a triangle or any side, when you are finding the magnitude, actually you know very limited geometrical and trigonometric theorems. Okay, what are those? The first one is Pythagoras. You don't want to think in wide range of applications, okay? Because you know very few things. What are those? Pythagoras. First one is Pythagoras. Second one is sin cos tan. Sin cos tan. Those are the only two things you know. Okay. Oh. I like the other. Okay, Buddha. Actually, what I was discussing, when you are asked to find a magnitude of a length of a side of a triangle or parallelogram or any other geometrical figure, actually you know very few things. No, you know very few things in geometry and trigonometry. What are those? The first thing, you know Pythagoras theorem. You know Pythagoras theorem. Using Pythagoras theorem, you can find a length of triangle, right angle triangle. The second thing is sin cos tan. If you know one side of a right angle triangle, and if you know an angle, then you can find other two sides using trigonometric ratios. Those are the two ways of finding a length. Do you get my point? Therefore, don't think very in very wide circle. Okay, don't think. Okay, because you know very few things. You know very few things. Using your knowledge, apply to solve this matter. How to do that? How to do that? බලන්න මම කඩාගත්තේදී එච්චර ඕගොල්ලන් තේරුම් ගන්න බලන්න ඒ විදිහට ප්‍රොඩක්ට්ස් මේ one by one step by step ඕගොල්ලෝ මේ point out කර ගන්න ඕනේ. හරිද? අර මුළු මේ range එකම හිතන්න එපා. තේරුමක් නැහැ ඒක. හරිද? කොහොමද මම one by one කොහොමද මම step by step මම කොහොමද මේ break down කරගත්තේ? Look at this. Actually, when I'm asked to find a length of a geometrical figure, I don't know very much in geometry or trigonometry. If I'm asked to find a length, I know only two methods. What are those? Pythagoras theorem and trigonometric ratios. Okay, because there is no any other relationship, something like some trigonometric some geometrical, there is no any geometrical figures here. Okay, like circles, some equilateral triangles, where those kind of things are not visible here. Okay, therefore I don't want to apply, I don't want to think in that way. Okay, therefore I have to apply one of these two methods. What should I apply? You know this length, no Buddha? You know this length. This length is equal to P. This length is equal to P. This length is equal to P because AB side represent the P vector in magnitude and direction. Therefore, I can consider the AB side is equal to P and BD side is equal to Q. Okay. Then look at this. This side, that means AC and BD are parallel to each other. Therefore, this angle and this angle are corresponding to each other. That means this is theta. Okay. Did you get my point? This angle should be theta. Okay. This angle is theta. If I know the length of this side, the length of this side and length of this side, if I know the length of this side, that means x and y. If I know the x and y, if I know the value of x, I will know AE length. No, because I know the length of AB. Length of AB is P. If I know the value of x, then I can find the length of AE. Length of AE is equal to P plus x. Then if I know the value of y, I know the length of DE. Look at this. AED triangle. Look at this AED triangle. AED triangle. What kind of triangle is it? It is a right angle triangle, no? It is a right angle triangle. Right angle triangle is a very good one, no? Because I can apply Pythagoras theorem. I can apply Pythagoras theorem because I know AE and DE. If I know AE and DE, I can apply Pythagoras theorem to AED triangle. Then I can find the value of R. Did you get my point? Everyone, I need the response.
Yes.
Okay. If you get my point, please tell me how to find x and y. How to find x and y. How to find x and y. We did this kind of questions, okay, in trigonometry. I will give a hint. What is the hint? I will extract BED triangle. I will extract BED triangle here. If I extract BED triangle here, this side is x, this side is y, this side is q, this angle is theta. I have extract BED here. Tell me how to find x and y. How to find x and y? You can apply trigonometric ratios, Putta. Trigonometric ratio, because you know the hypotenuse and an angle. You know the hypotenuse and the angle. Hypotenuse is q, angle is theta. If you want to find x, x is the adjacent side with respect to this angle. X is the adjacent side with respect to this angle. If you want to find adjacent side, what would be your trigonometric ratio? What is the most suitable trigonometric ratio if you want to find x? Go. Give me an answer.
Tan theta.
Tan. What are the known values, Putta? What are the known values here? You know the hypotenuse and angle. Hypotenuse and the angle are the known value, and you have to find the adjacent value. Hypotenuse, angle, and
Sin
adjacent
theta.
side.
Sin theta.
Sine. Cos. There. Cos theta is equal to the adjacent side over hypotenuse, no? Cos theta. From I can write here, here, from BED triangle. From BED triangle, I can write cos theta for expression. Cos theta. Cos theta is equal to adjacent side over hypotenuse. That's mean BE over Q. This is Q. BE over Q. Then I can find BE. BE means X. So X is equal, or BE is equal X. X is equal Q cos theta. It is Q cos theta. Okay. So this side is equal to Q cos theta. Likewise, find the value of Y. Find the value of Y. Y is the opposite side to the Q. How to find Q? How to find Y? Opposite side to theta. Opposite side to the theta. So how to find Y?
Sine.
Tell me. Then you have to use sine theta. Yeah, sine theta. Sine theta. If you use sine theta is at opposite side over hypotenuse. Opposite side over hypotenuse. Again, Y over Q. Y over Q. Then you can write Y is equal Q sine theta. Y is equal Q sine theta. So Y is equal Q sine theta. Okay. Okay. After finding this, I can determine the length of AE. The length of AE. The length of AE is equal to P plus X. P plus X. That means P plus Q cos theta. P plus Q cos theta. The length of BDE. The length of DE is equal to Y. That means Q sine theta. Okay. Then I can apply Pythagoras theorem for AED triangle. So applying AED triangle. You can write AD square is equal to AE square plus ED square. Okay. All right. Okay. Then I can apply these values to this equation. Then AD square means R squared. R squared is equal AE square. A means P plus Q cos theta. P plus Q cos theta, the entire square, whole square, plus Q sin theta square, plus Q sin theta whole square. Okay. Okay. Then now we can simplify this one, Puta. Then look at this. R squared is equal. You have to expand this one. If you expand this one, then you will have P squared plus the product of these two into two times product of these two, no? Yeah? If you expand this, you will have x squared, then 2 times xy plus y squared. Same thing you can apply here, p squared, then 2 times the multiplication of these two, that means 2 pq cos theta, 2 pq cos theta, then the square of second one. Square of second one means q cos theta entire square. If I may get a square here, then I will have q squared cos square theta. Okay, cos square theta. That is the way of writing. Cos square theta means cos ratio is squared. Okay. Don't write theta squared. Okay. Don't write this thing. Okay. Cos theta squared. Don't write this thing. This is wrong. That's why, because this means cos ratio of theta squared. Cos ratio of theta squared. Okay. But I should get the square of cos theta squared. Okay. Therefore, I have to write cos square theta. Cos square theta means cos theta into cos theta. That is the meaning of cos square theta. Therefore, I can write this one, q squared cos square theta. Then the final thing is this one. If I take the square of this thing, I will have q squared sine square theta. Then I can simplify this thing. R squared is equal to p squared plus 2pq cos theta plus, look at this, q squared cos squared theta plus q squared sin squared theta. Both have q squared. That means q squared is a common factor for these two terms. Okay. Then I can take that common factor out. If I take q squared out, I will have cos squared theta plus sin squared theta. Cos squared theta plus sin squared theta. What is this value? We have done in our trigonometrics. Sin squared theta plus cos squared theta is equal to sin squared theta plus cos squared theta is equal to 1, Puta. 1. This is equal to 1. Therefore, this value is equal to 1. We have done this in trigonometry. If you don't remember this one, please watch the recording again. Okay. So this value is equal to 1. If it is 1, I will have q squared only. Therefore, I can write this expression p squared. From that, I will have q squared only. P squared plus q squared plus 2pq cos theta. P squared plus q squared plus 2pq cos theta. This is the equation. This is the equation, Puta. This equation can be applied to anywhere. This is a standard equation. The standard equation for finding magnitude of resultant force. So it is equal to p squared plus q squared plus 2pq cos theta. Okay. Did you get my point? I need your response.
Yes, sir.
Sorry. Okay. If you understood, then you can draw this parallelogram again. Then from here to here, write the simplification. Quickly write that. Shall I erase this? Oh, I need your responses. Have you complete writing, Puta? Have you complete writing?
Yes.
Okay. Okay. Now we have determined the magnitude of the resultant vector. Magnitude of the resultant vector. Okay. But it is not sufficient. It is not sufficient because we have to find the both magnitude and the direction. Okay. When you are asked to find a resultant vector, you should give the both magnitude and the direction. Therefore, magnitude is not sufficient. How to find direction? How to find direction? Normally, the direction is defined as the angle between P and R. As the angle between P and R. This is actually, this is not a definition, that is a thumb rule. Thumb rule means it is not a hard and fast rule. It is a some thumb rule. Normally, we are taking this angle as the direction of the vector. Okay, because we know the direction of P, we know the direction of Q. So if we know the direction of P, with respect to P, I can give the direction of the resultant force. Okay. Okay. Alpha. We know the alpha. Look at this. In that case, I will extract AED triangle. I will extract AED triangle. Okay. If I extract AED triangle, AED triangle. If I extract AED triangle, this, look at this angle, DAE. DAE angle is equal to alpha. Alpha, which is the direction of the resultant vector. Alpha. You know this side. This side is equal to P plus Q cos theta. P plus Q cos theta. This side is equal to Q sin theta. So you know these two angles, because two sides, because you know the value of Q, value of P, as well as the value of theta. You know all of these. Therefore, you know this length and this length too. Okay. If you know these two sides, how to find alpha? How to find alpha? It is very easy, no? If you know these two sides, that means with respect to this alpha, that means relative to this alpha, this is the opposite side and this is the adjacent side. Opposite side and adjacent side. If you know the opposite side and adjacent side with respect to an angle, then what will be the trigonometric ratio corresponding to these two sides, opposite and adjacent? What will be the trigonometric ratio? It is tan alpha. No, it is tan alpha. Tan alpha means opposite side over adjacent side. Therefore, I can write an equation for tan alpha. Tan alpha is equal to opposite side. That means DE over AE, adjacent side. Opposite side over adjacent side. So what is the value of opposite side? It is Q sine theta. Okay. Therefore, tan alpha is equal Q sine theta over P plus Q cos theta. So this is the direction of the resultant force. When you are finding the direction, you can find the tan alpha, then you can subject alpha. How to subject alpha? Alpha is equal to tan inverse this thing. Tan inverse this thing. Alpha. If you want to find alpha, alpha is equal to tan inverse Q sine theta over P plus Q cos theta. Okay. These two equations means first equation is magnitude of resultant force, that is equal to R squared is equal to P squared plus Q squared plus 2PQ cos theta, and the direction tan alpha is equal to Q sine theta over P plus Q cos theta. Those are standard equation. You can apply this equation to for anywhere. Therefore, you have to remember this equation. You have to remember this equation. Okay, write this thing. From AED triangle, you can write this thing. Actually, this is the most important lesson in vector, Puta, because vector paragon theorem is the most important lessons in the vector, because you can have a lot of questions in this lesson. Okay, shall I erase this? Okay, I will erase this, Uta. Okay. Maybe you have to remember the trigonometric lessons which we have done earlier. Yeah, wait a minute. Look at this dude. We have discussed this thing, okay? In trigonometry, we have discussed this question. You should have this knowledge, okay? You should have this knowledge. If you don't remember this now, how to do these questions, please try it again. If you don't understand, please go to the previous recordings and watch it again. Okay, because you need to have this knowledge. That's why we did previously. Okay, please let me know. Do you have any question? Do you have any question? Do you have any question, Buddha? Regarding today's lesson?
Understood, sir. Thank you.
Okay. Then so this Sunday, this Sunday, there won't be any class. For that class, we will do we'll do an extra class on next Thursday. Okay. Therefore, in next Thursday, we will discuss some questions regarding vector paradigm theorem. Okay. Okay. Then we can complete today's class. I think you understood all the things. If you have any questions, please let me know after the class. Okay. Okay. Then good night all.
Thank you, sir. Good night, sir.
Welcome.